Inequalities in a triangle. Let's look at two theorems. If one side of a triangle is longer than another side, then the angle opposite the first side is larger than the angle opposite the second side. And a related theorem, if one angle of a triangle is larger than another angle, then the side opposite the first angle is longer than the side opposite the second angle. The measure of an exterior angle is greater than the measure of either remote interior angle. And the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So let's use one of those theorems in this example. To order the side lengths of this triangle, we need that third angle C's measure, which is going to be 80 degrees, from the triangle sum theorem. Now the shortest side would be opposite the smallest angle. So the side lengths go BC shortest, then AC, and the biggest being AB. Okay, a similar problem, but we're given the side lengths, and we're asked to measure the angles from least to greatest. The smallest angle is opposite the shortest side, that's angle Y. The biggest angle is opposite the longest side. That's angle X. All right, in the next example, we're to decide if the three numbers inside the parentheses could form a triangle. Let's consider 3, 4, 5. Well, of course, that could form a triangle. In fact, it's a very famous right triangle. Now let's consider 5, 11, and 6. That's a no, because 5 plus 6 is not greater than 11. And 1, 9, 5 would be no, because 1 plus 5 is not greater than 9. All right, the next example says find the range of values for x in the given triangle. So we're going to write our three inequalities, that the sum of any two sides must be greater than the third side. Then we'll solve those inequalities. The middle inequality we can get rid of, x is greater than -3, because of course a side length has to be greater than a negative. But putting the first and the third inequality together as a conjunction, you can write it as 3 is less than x is less than 11. Okay, that means x is between 3 and 11. It's greater than 3, but less than 11. Example 1a, let's find the measure of angle Q. And to order the sides from least to greatest, the smallest angle is across from the shortest side. Okay, watch the directions in the second problem. This says order the angles from greatest to least, so the biggest angle is opposite the longest side. All right, here we're asked to prove that first it says in the given triangle, angle 4 is an exterior angle. Prove that angle 4 is greater than the measure of angle 1 or the measure of angle 2. So let's assume that the measure of angle 4 is equal to the measure of angle 1. So we'll kind of prove this by contradiction. If they were equal, that will result in the measure of angle 2 being 0 degrees, because the exterior angle theorem of a triangle would say the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Okay, so therefore I know that the measure of angle 4 is not equal to the measure of angle 1. Now let's assume that angle 4's measure were less than the measure of angle 1. This would result in the measure of angle 2 being negative, which is a contradiction. Therefore, we've proven that the measure of angle 4 must be greater than the measure of angle 1 or the measure of angle 2. Okay, could these side lengths form a valid triangle? For the first set, that would be no, because 14 plus 6 is not greater than 20. For the second set, yes, because the sum of any two sides is greater than the third. And for the third set, no, 14 plus 10 is not greater than 25. All right, problem B, we're going to set up our three inequalities and solve for x. Again, toss out that middle inequality, but use the conjunction to write a compound inequality that x must be between 7 and 31. Okay, now a little application problem. A triangular course or a bicycle race has two sides that are 10 and 14 miles long. So what are the possible range of distances for the third side? So how could this be designed, right? So we'll set up our inequalities using 10, 14, and x. We'll solve for x. We'll throw out that middle inequality, and our compound inequality means x has to be between 4 miles and 24 miles, greater than 4 but less than 24. Okay, finally I have a little exit task for you. See how you do with this. Probably a good idea to draw a picture for number 1, right? And justify in number 2, could those side lengths be the side lengths of a triangle? Why or why not? And for number 3, find the range of values for x means write x in a compound inequality so that 10, 17, and x could be the side lengths of a triangle.